starting this final unit of the semester, and hopefully it's going to help take linear equations and make it a little bit more functional and connected to algebra, because we're going to be looking at ratios. And what was our limit for the slopes that we use this week? We're only supposed to use what kind of slopes? Sorry? Maybe whole numbers. I think we can be a little bit more expanded than whole numbers. Yeah, integers. Yes, so only integers. So ratios is going to give us the opportunity to think about slopes that are not integers. Okay, so that also means that we're going to be kind of thinking about fractions again. Let's start with some weekly notes. Okay, here we go. Help. If you're having issues with your 2Ts or the school site, please let us know. Like, contact us. Do not just put it in your surveys, because that's all de-identified so that you're not connected. Your name is not connected to your data. So please email us directly if you have any concerns or you want help or you have issues. Okay? Lesson plans, if you're unsure, please let us know. You can leave a comment in the comment box if there's a question about a certain part of your lesson plan you need help with. Please feel free to ask. And then schedules. If you are beginning to enroll and your schedule changes to where you're unable to work your shift, please let Christina know, because the earlier we know, the easier we can do something about it. Okay, we're going to start with a quick look. Please don't peek ahead. If you are on Canvas and you are being sneaky and looking at stuff ahead of time, that's going to ruin our conversation. Man. Okay, here we go. So thank you for helping me with that, Ethan. Okay, quick look. I want you to see as many things as you can remember about this image. Ready, set, go. One more time. Ready, set, go. What'd you notice? 5 yellows and 3 reds. Nice. Okay, what else? There's a coin in the corner. Nice. What else? Oh, a quarter is on heads. Okay. So does this look familiar? Do you remember this image? Perhaps? Okay, and maybe not. So in the pre-semester sessions that we had, this was one of the ways that we could introduce integers. But contrasting that this time, what are some other things that we could compare, some other kinds of statements we could make about what we see in this image, besides integer values? I'm looking for a dry erase marker and not seeing one. That sounded bad. Here's one. Let's see if this one works well. Okay, so what are some things that we could compare quantities of in this image? Coins to counters. And so that would be how many coins versus how many counters. How would we express that? 1 compared to 8. Or we could say 1 versus 8. 1 compared to. Okay. How could we use no?
Well, I'm recording it in my room on the desktop so that it's like you are bigger, you're half the screen, and it's fine to look at.
Okay.
There's
okay. Thank you, Christina. I don't know if the marker is going to show up at all there. Okay.
Paper? No paper?
Oh, like a poster paper? Yeah. Except I don't have a way to, oh yeah, it's sticky. Never mind. Okay. So mathematicians, we try to eliminate words as much as possible. Write things as succinctly and as just straightforward as possible. Maybe not straightforward, but we try to condense it as much as possible. So instead of these words, what strategy could we use to say the same thing using just symbols? Oh. Okay, a fraction symbol or a colon. Okay. Yay. in its first session. Okay. So instead of using all of those words to show the comparison of coins compared to counters, we could write it with symbols like this, or Ethan said we could write it like that. Is that what we decided? Okay. So how have we used this before compared to how are we using it now? What do we have one of? Coins. What do we have 8 of? Okay. Hi, Layla. This is different than the way we've used fractions before. How is this different? Or if we just read 1 out of 8 compared to what we see here, what are your thoughts? If you saw 1/8, would you think that it would represent this? Okay, because fractions, they might look like this, but what always goes on the top of a fraction? Numerator is the math word we use for it, but what does it mean? The parts, yeah, number of parts. And what always goes on the bottom of a fraction? Hi. The whole, how many pieces it takes to make a whole. Okay, but that's not what we compared with our ratio, right? We compared, what did we compare? Coins to counters. How does that relate to what we normally do with fractions? Because it's not 1 out of 8, right? Okay. So how do the way we're using ratios, what are we representing there? Part to part, okay? Coins are a part of the quantity and counters are a part of the quantity, right? Neither one of them represent the whole. So ratios can represent part to part. And that's what we did with coins and counters, right? What else could we compare with the image though? Can you say it a little bit louder? Red to yellow, okay?
I say 3 things, red to yellow to coins.
Okay, so what is the comparison of red to yellow? 3 to 5? 3 to 5, or I could write it as 3 to 5, or I could write it as 3 to 5. So if I know what I'm comparing, then I can state it any of these ways. But it's kind of important to know what those are, right? Which things am I comparing here? Okay, so that was another example of part to part. Yeah, Layla.
Aren't fractions and ratios like the same thing?
Well, I mean, when we looked at this, we said it was 1 to 8 coins to counters. How is that different than saying how we'd represent this as a fraction?
It's the same.
The same?
But it depends. Yeah, but it depends on what am I comparing, like the ratios.
It does, exactly. It depends on what I'm comparing. So fractions are,
I tried to talk, but you guys couldn't hear me.
right? Because I have my computer muted, so it won't.
Yeah. I was saying, could we do 3 things, since there's 3 different things?
We're
yellow
gonna
and
get
red?
there, Christina.
Oh, I haven't looked at the slides.
It's on the
I
slide.
just tried to actively participate.
Yeah,
Okay, I'm going back.
I'm sorry it's not working like that. Okay, so what's the difference between fractions and ratios? Somebody think they can explain it?
If you were to write a fraction, one nine, squared up. Parts over a whole. Parts of a whole.
Zoe?
I feel like with fractions, you're like representing the big picture, like how many there is of something,
Mhm.
you have the whole like picture there.
Uh-huh.
And then ratios, you're just like comparing those quantities within pictures of each other.
Okay. Okay, that's what we've done so far, right? We've compared one part to another part, whether it was coins to counters or red to yellow. What are some other things that we could compare using Christina's little suggestion as a clue, even? Red to yellow to coins. I'm going to shortcut because I'm a mathematician, right? So I'm going to shortcut what I write. Red to yellow to coins. I'm going to put a Q for quarter, like counters. So red compared to yellow compared to quarters. Now what are we comparing? One part to another part to another part. Okay, so what numbers should I put to represent this thing that I want to compare? What have I got? I know 3 compared to 5 compared to 1. Okay. Now, does this tell me, does that give me information about what I have in front of me? No? Yes? What doesn't it tell me, Ethan? Oh, so I need both. Are you saying that I need to know what the terms represent to make sense of this? Okay, and what does it tell us, Zoe?
It tells us like how many are in the pictures. There's 9.
Oh,
But
okay.
it's telling us like
Okay, so I could use these 3 pieces to find out what the whole was. Okay. Oh. Oh, so a ratio could be proportional to this or equal to this. Okay, so what I'm hearing is that fractions are more like narrow in what they can represent. They only represent a part compared to a whole, but ratios can represent different types of comparisons and not just part to whole, but they can represent part to whole. Now, what Michael just said adds this other dimension of ratios that just like when we had fractions, we learned that 1/4 equals 2/8, that those were equivalent. So we can have ratios that are equivalent too. That's not where I'm going to start with my 2 T's, but that's definitely going to be a part of our tasks and conversations this week. Yeah. So this represents exactly what I have here. Okay. But Michael was saying that 6 to 10 to 2 would have the same what? In what way would that be the same? You're good. You're doing great. Same proportion. Okay. All right. That's a very mathy word. Keep going. What else can we say? Be the same.
Ratio, I guess.
Same ratio. Great math word. How else can we say it?
it's the same number of points.
The same number of points?
So say it's the same. Not anything bigger, but it's scaled up. It's this. It's equivalent of the ratio.
Okay. So the relationship between this part and this part is the same. Like the way they compare to each other is the same. Even though it's scaled up or it's scaled down, if we're going to use a ratio, we want it to have the same relationship to each other. Okay. So 2 out of 8 has the same relationship as 1 out of 4 does. Okay. Now, right now, you guys are thinking about ratios from your perspective. That's awesome because you need to wrestle with like, thinking about it from a different direction. But your 2Ts are gonna need to wrestle with these ideas too. So instead of trying to put what you just thought through on them, ask questions to let them kind of consider possibilities for that. Okay? So give them the chance to compare different things and how ratios can serve different purposes than fractions can. Right? So that's where we start with this idea. Okay, so what is a ratio then? Ooh, I'm gonna write that down. What do you guys think about Layla's definition? How one quantity compares to another. Thoughts? Refine it, change it, verify it? Okay, so big idea from this initial task is that ratios are more flexible than fractions, but they still compare quantities. So in what ways are they more flexible? They can compare part to part or part to whole. Or they can compare part to part to part. Right? Or whole to part, or whatever we decide, as long as we clarify what the meaning of those terms are. Right? So if they're super flexible, we have to make sure that we're clear about which term represents what. Okay? Okay. Let's play. Well, we'll do this first. Okay, so we are, I don't know where to stand. We are right here. This is gonna be November, y'all. Did you realize November is here? November 7th through 9th. I don't see any interruptions at any school sites for this day. If you hear of something that is not on the calendar, please let us know. Okay? We go from introducing ratios, understanding how ratios work, to using ratios, using proportional reasoning to solve problems. And then we're gonna kind of narrow into percentages and decimals as special ratios that last week. We're also gonna use that last week to support some test taking kinds of thinking and strategies and really build students up in their confidence to make sure that they're excited and purposeful about the way they take their MAPS test. Okay, did you have a question?
No, sorry.
Okay, and you guys see that OU does not have the full week off for Thanksgiving, but your school sites do.
Yay.
Right? Yeah, so we talked about, and I can't remember now. Kayla and I figured it out. It makes so much sense. To not have a session on one of these days, not have a development session. I think what we decided was we're gonna use this session this day to plan for that week. And then you won't have to come this time on the week of Thanksgiving, the 19th, but we do have to have you come on the 26th. Okay? Or the last week of tutoring. Okay. All right, so broad overview of this unit. Hi, Simone, glad you're here. Week 12, understanding the purpose of ratios, using ratios to represent various relationships, representing these ratios in various ways, and generating equivalent or proportional relationships. So the next week, we're going to use it to solve problems, like solve for, well, if you had this many red counters now, how many yellow counters would keep the ratio the same? Okay, we're gonna wait for that for the next week. And then understanding equivalent relationships as parallel slopes. So taking that idea of ratios and moving it to the abstract kind of graphing idea, that'll be a part of next week also. Okay, so some common, this is kind of our idea of conceptual to fluent understanding, but I wanted you to see some common misconceptions. Students do not often see this relationship that Michael identified. They might add 3 here, add 3 here, add 3 here. So they want to change by addition or subtraction instead of multiplication with ratios or division. Okay. Common misconceptions, ratios are always part to whole, just like fractions, or the order of the terms doesn't matter. Those are common things that students might struggle with. Okay, so real world connections. What could we use ratios to represent that's immediately visible to us right now? Okay, that's where I'd like to start. Where can I see ratios around me? So come up with something. I've got a list here. Okay. Pick one that you and your partner can figure out your responses to, your partner, the person next to you, what your response would be to those. And then be prepared to share one other idea that might relate to your students' interests or your students' experiences. That would be a good ratio, a good relationship for them to think about. Okay, go.
Why do you want us like the desk? Like, hopefully you have more desks. You definitely do. So we definitely are. Yeah.
Yes, that's okay. Okay. I need a group to come write just the numbers that represent the ratio they identified. Come write it on our board up here. As many groups as are willing, come write your ratio on the board. Don't tell us what it's for, just give us the numbers. Thank you. Somebody else? Yeah, go for it.
I don't know the number.
You don't know the numbers?
I guess student dissertation.
Oh, okay.
I mean, here.
We could pretend that I'm teaching you. It's not, yeah, it's okay. Because in the classroom, that would be very relatable, very visual type of thing. Anybody else wanna put one up there without telling us? But yeah, both of you, go on up. Yes.
So I mean, the student we have.
13 of you.
Oh, I counted 12.
Oh, I counted myself, sorry.
Oh, okay.
Always for still learning.
Is that up in there? So it's on the
Sure.
paper. Okay. Yeah.
Oh, you did the one on there.
Are you doing the, you think you're doing the same one she was?
Oh, yeah.
Really?
Oh, wait.
Yeah, no, yeah.
Wow, that's so
Interesting. Okay. So I'm so curious now. We could play guessing game, couldn't we? Like that's what I want to do. Like my personality, I want to play a guessing game. But I'm really curious about the relationships that people thought. Does anybody want to throw a guess out there? They think they know what one of these is.
I know the first one.
You do the 5 to 2?
Yeah.
What do you think those terms are?
Weekdays versus weekends.
What? Oh, you think that's this?
Yeah.
Okay, is that right? It is. Okay. All right. I don't want to think about that. Does anybody else think they know? Okay, Ethan, you want to put a guess up there?
The 12 to 1.
Wrong. Okay. So is it accurate? Are there 12 of you college students right now compared to me? Okay. All right. So we could play a guessing game with this. I think that would be kind of fun. But the goal is that we practice identifying terms and representing it as a ratio. What if we wanted a little bit more detail about this? Right? What are some other things we could be a little bit more specific about who's in the room as far as students? And what were you thinking, Layla?
Teacher, undergraduate students, graduate students.
Okay. So where do I fit? Because I'm a graduate
That's
student.
true. I guess you're gonna be repeated.
Okay, so tutors that are undergrads, tutors that are graduate students, and a team lead that's
Yeah.
okay. Could we do that? Okay, how many of you are undergrads? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 10 to graduate students. 2 to team lead. Okay. Okay, so now how do we identify our terms? Undergrad, tutors, graduate, tutors, team lead. And we have to make sure we can identify our terms and that our numbers match the terms that we're representing. Okay, so make it richer. Which of these relationships would stay the same if extended to more sessions or more whatever, more samples? Which of these would stay the same and which of them would be varied? Layla, what are you thinking?
My ratio would stay the same.
Yours would. This one? And what is it?
It's number of eyes versus group members.
Number of eyes, is it 24?
Yeah.
Okay, 24 eyes compared to 12 group members.
Yeah.
Okay, yours would probably stay the same, very likely. Okay, huh? Number of eyes compared to, oh, okay. So if we looked at blue compared to brown, compared to green, would that ratio stay the same if we used our room and then expanded it out? Oh, okay, interesting. So that would vary. So eyes compared to people. I mean, your 14-year-olds are going to be like, some people don't have 2 eyes, some people lost an eye. I mean, that's going to happen, right? Yeah, that's going to happen. Okay. So some of these will vary, and you can extend it to a bigger set, and the relationship between them is going to stay the same, right? Which one of those on there will be the same regardless of how many we gather? This one? Does the calendar always work in that 5 to 2, 5 to 2? Unfortunately, okay. 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 Good point. Okay. So that's going to be an important part of extending ratios. Think about proportional reasoning and solving problems is that we have to assume that the relationship stays the same when the population or the data expands. Okay, so we could ask our tutees to come up with comparisons that would and would not vary. So other ideas, you guys did that already. Write those things as ratios. What would happen if we switched the order of our comparison? Right, so if I said 1 to 2 to 10, is that